What is power factor? Power factor is a measure of how effectively electrical power is being used in an alternating current, AC, circuit. It is the ratio of real power, measured in watts, to apparent power, measured in voltamperes, and it is expressed as a decimal or a percentage. In an AC circuit, the power consists of two components, real power, P, and reactive power, Q. Real power is the actual power consumed by the resistive elements in the circuit and is responsible for doing useful work, such as powering motors, heating elements, or lighting. Reactive power, on the other hand, is the power consumed by reactive components such as inductors and capacitors and does not perform any useful work. Instead, it oscillates between the source and the reactive elements. The apparent power, S, is the vector sum of real power and reactive power and represents the total power supplied to the circuit. The power factor, PF, is the cosine of the angle between real power, P, and apparent power, S. A power factor of 1 indicates a purely resistive circuit where real power and apparent power are equal. In this case, the current and voltage waveforms are in phase, and the circuit is using power efficiently. A power factor less than 1 indicates a circuit with reactive elements, and the current and voltage waveforms are out of phase. This leads to a decrease in power factor and less efficient utilization of electrical power. Power factor is important because it affects the efficiency of electrical systems. Low power factor can result in increased energy losses, reduced system capacity, and higher electricity bills. It is desirable to have a power factor as close to 1 as possible, and power factor correction techniques are employed to improve power factor in AC circuits. Why power factor is important? Power factor is important for several reasons. 1. Efficient power utilization. A high power factor indicates that a system is using electrical power efficiently. It means that a greater portion of the supplied power is being used for useful work, while a lower portion is being wasted. By improving the power factor, electrical systems can reduce energy losses and optimize power utilization. 2. Reduced energy costs. Electrical utilities often charge penalties for low power factor. This is because low power factor requires the utility to supply more apparent power, measured in voltamperes, to meet the real power demands of the system. Since utilities have to generate and transmit the higher apparent power, they incur additional costs. By maintaining a high power factor, consumers can avoid these penalties and reduce their electricity bills. 3. Increased system capacity. Systems with low power factor require more current to deliver a given amount of real power. Higher currents lead to increased losses in transmission lines, transformers, and other components of the electrical system. By improving power factor, the current can be reduced, allowing for increased system capacity and reduced stress on electrical infrastructure. 4. Improved voltage stability. Low power factor can lead to voltage drops and fluctuations in the electrical system. These voltage variations can negatively impact the performance of sensitive equipment. By maintaining a high power factor, voltage stability can be improved, ensuring reliable operation of electrical devices. 5. Compliance with regulations. Many countries and electrical standards specify minimum power factor requirements for certain types of equipment and industrial applications. Compliance with these regulations is essential to ensure safe and efficient operation, as well as to avoid penalties or legal consequences. 6. Environmental impact. Improving power factor reduces the overall demand for electrical power, which can help in reducing greenhouse gas emissions and environmental impact associated with power generation. Overall, maintaining a high power factor is important for optimizing energy efficiency, reducing costs, ensuring reliable operation of electrical systems, and meeting regulatory requirements. It is beneficial for both individual consumers and the larger electrical grid.